Let's take a look at finding the derivative of the function f of x equals x squared plus 1 using the limit definition. And once we have that derivative, that f prime of x, then we want to find the value of the derivative at the point negative 1, 2. So we will be using this definition of a derivative to help us with this work. So f prime of x is going to equal the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So I'm going to be replacing in this first part of my numerator, I'm replacing x with x plus delta x in my function. So I'll have the limit as delta x goes to 0 of, we'll have x plus delta x squared plus 1. That's my f of x plus delta x. That's this first piece. Minus f of x. Well, f of x is simply my function. So x squared plus 1, all divided by delta x. Now, I can't take this limit at this time because as delta x goes to 0, my denominator would go to 0. So I need to use some algebra and simplify my numerator and see if I can rewrite this function that we've created in a simpler term so that we can actually find the limit as delta x goes to 0. So continuing on, limit as delta x goes to 0. If I use the distributive property on x plus delta x squared, I'm going to get x squared plus 2x delta x plus delta x squared plus 1, and then minus my x squared plus 1, so I'm going to minus x squared minus 1, distributing that minus sign, all over delta x. Now, if we look in our numerator, I can see that I have a positive x squared and a minus x squared. Those will add to 0. I can see I have a positive or plus 1 and a minus 1. So those will add to 0. So all I have left is this 2x delta x and this delta x squared. So I will factor a delta x from each of those terms. So we'll end up with the limit as delta x goes to 0 of delta x times, from my first term I factor out delta x, I'm left with 2x, plus from my second term factoring out a delta x will leave me with a delta x. Then all of that over delta x. At this point, I have a common factor in the numerator and the denominator of delta x, so they will divide out, and I'm left with the limit as x approaches 0 of 2x plus delta x. At this point, I've resolved the issue of delta x approaching 0 causing the denominator to be 0. So now we can consider the behavior of this equivalent function. Now my equivalent function, as delta x goes to 0, 2x will just go to 2x. It is not affected by delta x. And as delta x goes to 0, so this delta x in my function will also go to 0. So what we've discovered is that f prime of x is equal to 2x plus 0, or more simply, equal to 2x. Now we are also asked to find the value of the derivative of the function at the point -1, 2. Now as I look at my derivative, notice that the input for a derivative function is an x value. So when I want to find the derivative of a function at a specific point, I need to know the x value to accomplish that. So the derivative of the function at the point -1, 2 will be f prime of -1, which would be 2 times -1, which would be -2. I hope this helps.